You're standing on a beach in Norway, 793 CE. The morning fog is thick. Then you see it, a shadow emerging from the mist. A ship unlike anything you've ever seen. It's moving fast, impossibly fast, cutting through the water with almost no resistance. The hull sits so shallow it can navigate rivers that would trap any other vessel. Yet somehow, this same ship just crossed the entire North Atlantic Ocean. This is a Viking longship, and it didn't just change warfare, it revolutionized ocean travel for the next 500 years. But the question that has puzzled modern shipbuilders remains: how did Vikings create the most advanced ships of their era using nothing but axes, fire, and an understanding of wood that we've completely lost? While most people think of Vikings as brutal raiders, their true genius was in engineering. They built ships so advanced that modern boat builders still study their techniques today. In this video, we're uncovering the hidden innovations that made Viking ships the most versatile vessels ever created. From flexing hulls that absorbed ocean waves to navigation methods that worked without compasses. Are we missing something obvious about ship design that's been hiding in plain sight for over 1,000 years? But first, let's solve the mystery of how Vikings made ships that could bend without breaking. It's 1880. Norwegian archaeologists are excavating a burial mound near Gokstad. They uncover a Viking ship buried for over 1,000 years. The wood is remarkably preserved, but when they try to understand how it was built, they're confused. The planks aren't rigid. The ship wasn't designed to be stiff like modern vessels. It was designed to flex. Modern ships are built with rigid frames to prevent cracking. Vikings did the opposite. They discovered that a ship that could flex with the waves would actually last longer and move faster through rough seas. But how did they make wood flexible without it breaking apart? The secret was clinker building. Instead of placing planks edge to edge, Vikings overlapped each plank and connected them with iron rivets. This created a hull that moved like a living thing. When waves hit the ship, the overlapping planks could shift slightly, absorbing the impact instead of fighting it. The entire hull would twist and flex, sometimes by as much as 15 centimeters, yet never break. In 1893, Norwegian Captain Magnus Andersen built an exact replica of the Gokstad ship and sailed it across the Atlantic Ocean. During the voyage, he reported that the ship moved through storms like a seagull on the waves. The flexing hull had turned the ocean's force into an advantage. Vikings weren't fighting the sea. They were working with it. But a flexible hull was only part of the innovation. Vikings also solved a problem that naval architects wouldn't figure out for another 800 years. You're a Viking warrior preparing to raid an English monastery. Your ship draws less than 1 meter of water when fully loaded with 60 warriors and supplies. This means you can sail up rivers that no other ocean-going vessel can access. You beach the ship directly on shore, jump out and attack before anyone even knows you're there. When you're done, you simply push the ship back into the water and disappear. This was the Vikings' secret weapon. Most medieval ships had deep hulls that required harbours to dock. Vikings designed ships with almost flat bottoms. The keel was relatively shallow. This allowed them to navigate in less than 1 meter of water while still being stable enough to cross the open ocean. But here's what's remarkable. That same shallow design that let them raid rivers also made them faster in the ocean. Less hull in the water meant less resistance. Viking ships could reach speeds of 15 to 17 knots in good conditions. That's faster than most medieval ships that were twice their size. The Vikings had accidentally discovered hydrodynamic efficiency 800 years before it became a science. The design was so effective that when William the Conqueror invaded England in 1066, he didn't use traditional ships. He used Viking-style vessels, because nothing else could move troops and supplies as quickly. But speed and flexibility meant nothing if you couldn't navigate. And Vikings solved that problem in the most ingenious way. You're sailing from Norway to Iceland in 950 CE. There are no landmarks, no GPS, no magnetic compass, just endless ocean and sky. Yet somehow, Vikings made this journey regularly, navigating over 1,000 kilometers of open water with remarkable accuracy. How? For decades, historians assumed Vikings simply followed coastlines and got lucky. Then in 1948, a Danish archaeologist discovered something unusual in a Viking shipwreck, a piece of crystallized calcite. At first it seemed like random cargo, but researchers began to suspect it was a navigation tool. The crystal, which Vikings called a sunstone, had a unique property. When held up to the sky, even on cloudy days, it could detect polarized light from the sun. By rotating the crystal and watching how light passed through it, Vikings could determine the sun's position even when hidden by clouds or fog. In 2013, scientists proved that sunstones could locate the sun's position with accuracy within 5 degrees, even in completely overcast conditions. Vikings also used shadow boards, simple wooden discs with a central pin. At different times of day and latitudes, the shadow would fall in predictable patterns. By tracking these shadows, Vikings could maintain their latitude while crossing the ocean. It was celestial navigation, using nothing but wood and observation. But perhaps their most impressive technique was reading the water itself. Experienced navigators could detect land by watching wave patterns, observing birds, even smelling the air. They knew certain seabirds only flew within 100 kilometers of land. They recognized that waves changed direction when reflecting off distant coastlines. Vikings had turned the ocean into a map that only they could read. You're approaching a Viking ship in harbour. At the bow, a carved dragon head rises from the wood, mouth open, eyes staring. Most historians assumed this was just decoration or intimidation. But recent analysis suggests the dragon head served an engineering purpose. The carved prow pieces were removable. Vikings would attach them before battle or when approaching foreign shores, then remove them during ocean crossings. Why? Because the dragon heads acted as wave breakers. The curved design would split incoming waves, reducing the amount of water that crashed onto the deck. It was functional art. The entire ship was a demonstration of woodworking that modern craftsmen struggle to replicate. Vikings shaped planks using only axes and wedges, following the grain of the wood to maintain its strength. They sealed gaps between planks with tarred animal hair that would expand when wet, creating a watertight seal. Every choice was functional, elegant, and nearly impossible to improve upon. So are we missing something obvious hiding in plain sight? Almost certainly. Modern ships are engineering marvels of steel and computers. But they've lost something Vikings understood intuitively. Work with your materials, not against them. Design for flexibility, not just strength. Let nature guide your solutions instead of forcing yours onto nature. Vikings didn't have metallurgy for steel hulls, so they became the world's greatest woodworkers. They didn't have engines, so they mastered sail design and hull shapes that extracted every bit of energy from wind and waves. They didn't have navigation computers, so they learned to read the ocean, sky, and wildlife with precision that matched any instrument. The Viking longship wasn't primitive technology. It was the peak of what could be achieved with wood, rope, and human observation. And in many ways, we still haven't surpassed it. Modern replica Viking ships regularly outperform their size class in sailing competitions. The designs that conquered the North Atlantic over 1,000 years ago are still competitive today. The next time you see a sleek modern yacht, remember that Vikings achieved something similar with nothing but axes and understanding. They didn't just build ships. They revolutionized ocean travel by understanding principles we've since forgotten in our rush toward complexity. If you made it this far, hit subscribe. There's more where this came from. Thanks for watching.